Hey guys, Professor Doney back. We're in the middle of talking about circuits, again specifically simple DC or direct current circuits. Have a simple circuit drawn here. We have a voltage source that's 100 volts plus minus. There's a symbol for it. We have over here on the right side a device or resistor or something that's causing resistance or giving resistance to the flow of electrons and current, and it has a value of 20 ohms. Now what I've also put down here is a little S or a switch, meaning right now the switch is open. There is no continuous path from the top of the voltage source to the bottom or the positive to the negative. There's no continuous path. So in this situation we would have zero current flowing. There's nothing going to go. It's not going to turn on, the device isn't going to work, things like that. Now once I close that switch, and put it down there, so now I have a continuous path, what happens is current is not equal to zero, and we would expect the current now to flow. And if we use conventional direction, it's going to go from the positive pole to the negative, or positive electrode to the negative. Okay, so let's say we've closed a switch. So go away switch, and current is flowing. There's I. And if we have 100 volts there, we have 100 volts all along this line. We have 100 volts right up to here. And on the other side, we have 0 volts because that has to be the zero side of potential. But we'll talk about that in another video. So what do I need to do here? Well, we're going to find a couple things here. Let's find the total current going through that loop. So we'll start out there. To find the total current, that is in Ohm's law, V equals IR. Voltage is 100 volts. I is I. Resistance we're given as 20 ohms. If we solve for I, it tells us that I is going to be 100 over 20, which equals 5 volts per ohm, which we more commonly call amps or amperes. So it's going to be 5 amps. Now, I'm told if you lick that, like if that was a battery and you wanted to test a 9-volt battery, which I know you all do, that would be a lot. And one of my students likes to say that, can you lick that to test it? And the answer is yes, one time. So that's a lot of amps going through there. When you test a 9-volt battery by looking at it, it's somewhere in the order of like 0.001 amps or 1 milliamp. So this is 5,000 times that. So certainly not something you want to do. Alright, so that's our total going there. What else can we find here? Well, if I know the current, I can go through and find out how much power this circuit requires to operate. And power is current times voltage, or I squared R. Let's do both of them just to check. I times R is going to be, or I times the voltage is 5 times 100. That's going to give us 500 volt amps or amp volts, but we refer to that as watts. So 500 watts to operate that. Now if we check it with the I squared R, that's going to be 5 squared times 20. That's 25 times 20. That should also give us 500 watts. So either of those work depending on what you are given. Okay? So we found the power that works in there and that. Now if this was going to operate for an hour a day, we could find out how much it would cost to run this, and I'm not sure we're going to have the time to do this in video, but we'll continue that in the next video, and we'll just use this same information. So alright, simple start to find the current flowing through the circuit and going from there.